I want to do this workshop as a follow-up to a session I did with Dome Dialogues earlier this year. So it was like back in May or June, I did a Dome Dialogue session on working with OpenSpace. And actually, let me, in case you have not seen that, I don't want to call it mandatory viewing um, for this. But I do want to, and hopefully everyone can, if you have not seen that, it is on the Dome Dialogues YouTube channel. So you can go there, you can watch that. And in that one, I get a lot into some of the basics of just how to install OpenSpace, which was sort of born out of, I was doing a lot of helping people install OpenSpace. So they had a robust streaming option for doing new stuff from home during COVID. And as I answering a lot of one-on-one questions, so that it'd be easier. Like, okay, let me just walk everyone through the basics of how to install the program, open it up, and do a few things in it. So I want to do a little bit of that today. But part of what I want to get to with opening OpenSpace is I wanted to crack under the hood a little bit and show you how to actually, where the things to manipulate in OpenSpace actually are, how to make custom shows with it, how to potentially add new content, and just where to look for how to expand and make cool use of OpenSpace. So let me unscreen share for a moment.
Am I early? I must be. I just stepped in the door here. Is everyone still in the other session?
Yep, we're just starting. You're on time.
Oh, okay.
Yep.
That's good.
Yeah. So I'm actually going to switch now and just share my whole primary monitor. So except let me get Zoom out of the way so that we don't get a giant recursive loop. And I can't see the chat, so maybe Waylena, if anyone does have questions in the chat, feel free to share those with me. Or if you just want to unmute to ask a question, that's also fine. It's really weird, like the complete silence otherwise. Yeah, so for starters, yeah, go a little bit into just some of the basics of downloading, installing OpenSpace. I did suggest, if possible, to download it ahead of time so that you can see some of where I'm following along. But I also know the install instructions aren't necessarily complete or intuitive. So if you didn't get that far, we'll step through some of that too. And just as kind of an introductory thought to this, I just want to sort of pose the question in general of, thinking back to in your career or before that even, of when you went to a planetarium at some point early, or what's the first time you remember having like a really moving experience in a planetarium? The first time that the planetarium created some emotional, evocative experience for you as you were seeing it. And the reason I want to think about that is, there any of us who've been in the industry for long enough have heard a lot of fights about, full dome versus optomechanical and the various technologies. And, back in the day with slide projectors. And certainly I started my career at the end of the slide projector era and have transitioned into full dome. But one of the things I really want to bring up about that, of course, is what's the point of what we're doing, of course, is, I don't think technology is important in and of itself. I don't believe a planetarium creates a meaningful experience to the audience just by existing, just by having cool tech. It's all about these experiences that you create for the audience. And I was thinking about that question specifically because one of the experiences I remember visiting a planetarium that really stuck with me was not my first planetarium visit, although I certainly remember those, but when I first went to Adler's Star Rider Theater when that existed. So that must have been like 99, 2000. My family took a trip to Chicago and we watched a show in Star Rider, and it was there. I don't know if Mike can probably tell me this, if they even made more than one show for Star Rider. But certainly the one I recall was about, colonizing Mars. And it was the first time going to a planetarium where you had the experience of like flying over the planet in full dome, not just as like an inset video window. Flying over a planet in full dome, sitting down onto the planet and seeing like, this simulated city on the planet, somewhat informed by seat button choices. But I want to get to that because, of course, I think that's what we're doing in this industry is we're trying to create inspirational moments for our audiences. I've probably said many times, like, I don't believe that we can comprehensively teach astronomy in a 30, 45-minute visit to the planetarium, but hopefully we can create experiences that inspire and create awe in our audience and encourage them to learn more and do more on their own. And I think that's one of the great things that OpenSpace provides. I certainly think that, it's for those who don't know, it is a open source software development project funded by NASA, led by AMNH and Norrköping University. So basically the same team that developed what would become UniView about almost 20 years ago. Sorry, I'm saying a lot of ums. You know how it is. I think it's important, though. It's not a fully featured piece of software yet. I don't think anyone should look at it as a replacement for your other Planetarium software. But I think it can do some really unique and cool things. And part of what makes it so great, and this is something that's true of Worldwide Telescope as well, is you can use it in your Planetarium. You can show people, create these experiences for them, and then you can tell them, you can download this at home. You can look in more detail at these same things that we saw, or go and explore more things right at your fingertips. I think that's an amazing potential the software has, and something that's been really great for using it during COVID. And Mary Holt will talk more about that in her paper later today. So I think it's a great tool. I think it's worth exploring, but it's also very confounding because it is so early in its development stages. At this point, it's about 5 years old, but a lot of features of it, including just its GUI, have only been developed within the last year and a half. And I've been lucky, since Cal Academy is a partner with AMNH on this project, to go and get a lot of firsthand communication about how to work with OpenSpace and how to use it. And several moments that have sort of been like these amazing switches turning on for me of how to use it, how to manipulate it, how to do new cool things with it. And so I want to share some of those insights with everyone else so that everyone has the chance to use OpenSpace and do cool stuff with it. So yeah, let's dive in. First thing I mentioned, of course, is downloading it. So OpenSpace, if you don't know, is at openspaceproject.com. That's worth knowing and looking up because there are several other things called OpenSpace, including just like websites for like parks departments and stuff like that. So, and I can never remember like openspaceproject.com. So, if you Google it, you should be able to find it eventually. It's obviously the site that has like planetarium-y looking stuff on it. And the core things you need are all on the OpenSpace website, as they should be. You can go to the download links to download the latest version of OpenSpace. I will note, currently, the team is talking about making a new release in the next week or two. So, it's worth, if you want to start playing around, of course, downloading these and playing around. But there will be a new release coming out shortly with a bunch of new features and further development. So I'm very focused on version 15 because that's what we have. I have not gotten to play around with version 16 yet myself, but this is a great starting place, and it's what's available. So yeah, you should be able to download OpenSpace for your operating system, and I think it will automatically, try to detect your operating system and offer you the download that's right for you. The software definitely, in my experience, it's easiest to use on Windows. But part of that might be the limitations of my own hardware because, there's a lot of things for like Linux version control. Similarly, in order to like sort of have it compatible with Mac OS, it is only compatible with the most recent Mac OSs. Because we work in a production environment here at Cal Academy, I actually run out of date Mac OS, so I can't even load OpenSpace on my Mac. And one caveat I gave a lot of people in the last session is currently, if you are going to use OpenSpace 15.1 and up, and this will probably, but not necessarily be true of 16 and up, you need to be using Windows 10. And that's because they have been currently developing touch features for OpenSpace that rely on Windows 10, because Windows 10 has, obviously like touch panels become part of our life. Windows 10 has much more sophisticated touch interaction features than previous versions of Windows. And because it's built into the software core, it's just not going to work on older versions of Windows. So if you are working on Windows 8 or 7 or below, you should still be able to run version 15, 14, 13, and so on, but not necessarily the higher versions. And I've been told they're going to keep implementing Windows 10 specific features. So something to keep in mind. I just went through the process during COVID of upgrading every single one of my Planetarium rendering machines to Windows 10 so that we can continue to advance with this. I know it's a pain, but it might just be necessary in some cases. In addition to downloading it, and there's a few like very important notes that I think are like not necessarily highlighted strongly enough on the website. So one of those key ones is you need to have the 2019 Microsoft Visual C++ redistributable. Otherwise, it just won't open. It won't work. And it's a really easy thing. It's not really highlighted very strongly. And it's one of those things I know has tripped a few people up of download OpenSpace, you install it, and then it just won't launch. This is one of those first things to check is to make sure you have that redistributable and you have the right version for your OS. If you have a 64-bit OS, 64-bit, 32-bit, 32-bit. This is important too. If you've previously used an older version of OpenSpace, version I think 15.1 and up do require the 2019 Visual C++ redistributable. Previous ones used I think the 2017. So there is new stuff in there. If you have the old version, again, it won't work. Got to download the new version. Similarly, there are some additional data sets that are worth downloading too to give you more robust things you can do with OpenSpace. There are packets of high-resolution Mars, Mercury, and Moon imagery that you can download and extract and install. Highly recommended, but they are gigantic, which is currently one of the balancing acts of OpenSpace. Part of what I like about the software so much is it's got this really strong focus on using high-resolution planetarium map data. This is something I've been advocating for use of in Planetarium software for a long time. And I think, Uniview did a great job when they implemented Geoscope as developed by Illuminati. Obviously, ENS is making great strides with their, I don't know the exact name of the tool, but, they've obviously been adding high-resolution map integration tools. I think it's something where, I strongly believe like this is a big future frontier we should be exploring in planetariums. And part of what I like about it so much is it's about transforming the way we look at these planets. I've often said like, coming from like the slide era, it's like, yeah, we had like these beautiful pictures or artwork of the planets, but they're just sort of like reflective of our immediate experience of them. They are dots in the sky. We can enlarge them through telescopes. But for the last, I guess, 23 years at this point, we've had a direct, real experience of rovers on Mars, of these planets not just being a distant point of light you look at with a telescope, but of being real worlds that we can visit and have experiences on. And that's what I think is important to offer to our modern audiences, is creating those experiences of we can traverse the human scale to the cosmic scale and back down to the human scale in another world. I think that's the really cool power that planetariums have right now, and something that OpenSpace does really, really well. So highly recommend downloading those extra packets of data. And I'm going to talk a little bit more about using those, some of the other data resources available, and even hopefully some hints at how to add your own, because that's something we've done a lot of here at the Academy too. As far as installing OpenSpace, it's really fairly easy to install because you don't really have to install anything. What I recommend doing is make a folder somewhere that you can access very easily, especially on a large hard disk drive, and call it OpenSpace. And when you download OpenSpace, you'll download something like a 60 gig. That sounds too big. Maybe not 60 gig, but some size of zip file. And all you have to do is unzip it. Unzip it, and you should just be able to create a directory that looks like one of these. I've got several versions of OpenSpace installed right now, not 15.2. Once again, because of compatibility of the shows we've been doing, we've been sticking at 15.1 currently. But yeah, you just open the folder and unzip it. Actually, I think I have one right here. Let me pull that onto the right screen. So yeah, open it. You have the folder, and just drag it into the folder you want to drag it into. One thing I'd recommend doing in addition in this folder is creating a folder called OpenSpace Data, all one word, because this will be the default place that OpenSpace will look to for high-resolution map data. Basically, it's already programmed into the core of the software, and this is a changeable feature, but by default, it's going to look up one directory from where the OpenSpace install itself is, and look for a folder called OpenSpace Data, and that's where it's going to expect high-resolution map data to be. If that's not where you want to put things, you will have to change something in the config file so it knows that, but the easiest thing is to just keep it on the same drive. And so in my case, I mean, you can see my desktop. I don't keep the cleanest computer desktop, and I keep my OpenSpace folder right on the desktop, but I also have my drive set up so that that's actually my large data drive and not my OS drive. OS is an operating system, not as an OpenSpace. So I have plenty of space to store and add a lot more OpenSpace data than just what's built in. So if you download the extra map packs, the Mars, the Mercury, the Apollo packs, this is where you should put them. Is in the OpenSpace data. Again, unzip them here, and they should basically be one directory flat of, a directory like Moon, Mars, Mercury for those basic ones. And then they should have inside of them several individual files, which are the individual map files. Now, obviously, you can create, if you were to add your own maps, multiple tiers of organization. There's no reason not to. But for the defaults, you basically just want to make sure you don't accidentally create like a moon directory or something like that. Just one level of hierarchy in the directory structure. And
yeah, and if my computer doesn't have enough memory and can I put it on an external hard drive? Would it run from that?
To my knowledge, yes, because it's effectively not installed as a typical program would be. And there is also the lightweight installation of OpenSpace, which might be worth trying for that too. But yes, you should be able to run it off of a external or flash drive if you have the space to put it there. It might not run as fast as you might desire because it's got to go back and forth over the USB cable, but it should be doable.
Somebody had asked in chat about that lightweight installation. Can you talk more about what it is?
Unfortunately, not completely, because I have not done very much with it myself. Yeah. And I also avoid it myself because I do keep these redundant versions of the software. I think the lightweight installation will, if you already have an existing installation, just upgrade the changes of OpenSpace without completely creating a new directory. And that's semi-important because when you download and open OpenSpace, it's not going to have everything in it. I might not even be able to show an example of that because I've put so much stuff into it. But one of the things that OpenSpace does, one of their focuses has been sort of helping to make sure that everybody has the same packages of data. And so the first time you launch OpenSpace, or the first time you launch OpenSpace with a new asset in it, it's going to go and talk to the OpenSpace servers, which, there's a few around, like there's one in Sweden, I think there's one in Utah, one at AMNH. It's going to talk to those servers and ask to download all the files it's missing. And this is basically their method of ensuring that everything is synchronized, everybody has the same files, they're uniform, and it populates this sync directory inside of OpenSpace, which is where everything that you download lives. It's not the only place things have to live, but it is where all the things that are built into OpenSpace live. And so, yeah, definitely don't launch OpenSpace for the first time when you're on a deadline, because it can take several minutes to download all of these initial data sets. Especially in version 15, they added a really nice volumetric model of the Milky Way. I think, based on the work AMH did for their Dark Universe show, but that model is about 0.5 gigabyte all on its own. And OpenSpace uses a torrent-like protocol to download files. So, it downloads lots of little things and small parts and assembles them back together. So it is not necessarily the fastest download to assemble all these things. So it's just good to keep in mind. That is something that can happen to you.
Hey, Dan.
Yes.
I have a previous install of OpenSpace 0.15.1. So if I get that lightweight install, do you know if I extract that zip into my existing directory or make a new one and copy over my old sync directory?
My guess would be unzip it and merge it into the current directory, but I can't say for sure.
Okay.
Yeah, sorry, I don't have complete information about the lightweight installs. And like I said, I don't use them as much, and especially because I do a lot of modifications of OpenSpace. I do a lot of manual, download the new one, copy in stuff from my old versions and things like that.
So the first time you open that, those data sets start downloading automatically?
Yep. And so when you first download OpenSpace, one thing I would suggest doing, I am in the OpenSpace directory created now. I'm going to go into the install for the version I'm using. The very first time you want to launch OpenSpace, I would suggest launching it sort of the old school, very manual way. So here in the directory, there are several folders. We're going to dive into some of these, but bin is the one that contains the binary executable for OpenSpace, as well as several other like packages. But yeah, down in here, OpenSpace.exe, that would be the way I'd first recommend launching OpenSpace, because that's going to sort of give you the first chunk of information on if everything is right or not. And I think that's important because there isn't a launcher for OpenSpace, which I'm going to get into. But if you have an error with your install or you're missing that Visual C++ redistributable and you try to launch it from the launcher, OpenSpace just won't open and you'll get no error message. Whereas if you launch it from the binary, you can still get some useful error messages. And so when you first launch OpenSpace, you might have seen two windows appear. One of them is this command line window, which is going through basically OpenSpace doing everything that it's doing, which is a great way to know that OpenSpace is doing something because it can take several minutes to initialize a show. And you can see it's building everything that's supposed to be in this profile I've loaded. And it's loading the default one by default, as one might imagine, with a name like default, including that you might have seen it pause a little bit there on checking that Milky Way is there and things like that. Because I've already launched OpenSpace several times, it doesn't need to download new information. But if it were, this other window is the actual like OpenSpace interface GUI window. And you would be seeing in this window little things appear to tell you that OpenSpace is downloading something, which is good, as you should have. And you should sort of get little progress reports of what's downloading. And you can just sit there and drink some tea and watch as it happens. So yeah, I have now opened OpenSpace. I do have some errors, which are probably related to things I've modified. In fact, I'm pretty sure I know what they are. But I have the default profile. I can see that it's working. I can see I have the Earth. I have trails. I have basic assets. If I didn't have that and I needed to figure out what had gone wrong, it's pretty hard to look in this command line window and actually see what's been going on. Things move very fast in it. You can't really like search in it. And also, by the way, just in case you have never used a program like this, never close this window, this command line window, because if you close it, it will close everything else too. So it always needs to be open in the background. But if you want to get a more detailed look at what OpenSpace has been doing as it's been loading, going back up to the root directory and going into the logs folder, there are two files that populate in the logs folder. Both of them important. I'm going to dive into the other one a lot more. But this one, and I don't know why Edge is my default thing it wants to open it with, but if I open up the log file, this is an HTML version of everything that just happened in that command line window, and which is great because you can use it to find what these problems were. This, I think, is an old asset that I've sort of kept populating through. And then, yeah, it's a great way to, you can go in and you can check and you can see what your actual errors were if OpenSpace fails to start or if it does start and something looks off. This is the way to find out without having to like scroll through and just look for red text in that command line window. Opening this log in a web browser is the best way. And I would definitely recommend opening it in a browser because it is sort of like auto-generating this HTML format. So if you open it in a text editor, it's like unreadable. So yeah, one case of like, we're going to do a lot with a text editor, but open it in a browser. It's one case you want to see it like that. I'm going to close this OpenSpace window, and I think I want to spend most of my time in another profile that I built of OpenSpace. And so the next thing I'm going to do to launch a different OpenSpace profile, one that I've customized, is I'm going to use the OpenSpace Launcher utility. Again, in your root install, you can find OpenSpace Launcher, and this will contain OpenSpace Launcher's executable. This executable I have also pinned to my taskbar, so I can open it up easily. You can also make a desktop shortcut or whatever you want to get to it. Just don't actually drag it out of this folder itself because it does reference these files in the folder to work. So if you drag the actual executable, won't work. I feel like pretty, we've all been there, I'm sure. But this will open the launcher. It also has some profile editing abilities, but they don't work super great. And one of the things that is coming in version 16 is more robust profile editing. So you could try editing here, but I've found it to be very inconsistent with how it handles the hierarchy of data within OpenSpace and what it can and can't load. So I'm going to show you how I create profiles manually, or scenes. The name has been getting kind of interchangeably used because there's a lot of UniView legacy here too. So for scenes, there's several built-in scenes that come with OpenSpace. They're all worth checking out. There's a lot of cool stuff, a lot of very you can see the really great data work that has been put into OpenSpace to take these various missions and deliver a data-based approach to integrating that into Planetarium software. So if you do the New Horizons one, you can follow along with New Horizons as it was flying by Pluto and whipping around to take all of its pictures. Same for Juno, OSIRIS-REx, Rosetta, following those missions. One that I think is particularly cool, but definitely needs a little bit of exploring around to make any use of it, is the Gaia profile. I think 2 years ago, I did a paper on the work we were doing here at Cal Academy to take Gaia, the initial data releases from Gaia, and actually make something out of them that could be seen in a planetarium, because Gaia is an enormous wealth of data. It gives us the position and velocities to about 1 billion stars, of which, when you sort of pare down the data, there's a few tens of millions that actually have good complete data that you can really build something visualizable with. But it's such an enormous mass of data that it's very hard to implement in a lot of our existing software packages. So it's one case we had built that out in UniView 3, because UniView 3 has the 64-bit support to handle enormous data sets being loaded into it. But OpenSpace has become a really great tool for visualizing these kinds of very large data sets, in particular Gaia. They also have the added benefit, of course, of Jackie Faraday at AMNH is very invested in Gaia research and understanding the motions and positions of stars. So she and her team and interns did a lot of the work sort of building what was initially a fork of OpenSpace that has, I think, been integrated back into the main build. But this is a great way to see those millions of stars, see their motions, see a lot of cool ways you can manipulate this data to see this amazing data that's come down from the Gaia satellite. And the amazing things it's revealed about the structure of our galaxy, about the different populations of star motion in our galaxy, including even that, we can see evidence of galactic mergers in our existing galaxy. So that's a data set really cool to check out. Well worth checking out. I'm not going to dive into it too much, because you could probably do a whole workshop just on how to fly with Gaia. It certainly took me a few days when we did a talk with them. Instead, I'm going to load up a custom profile that I built up for the American Geophysical Union conference when they came here last, December. Time is a blur, obviously, right now. So I'm going to load that up. And this has a good variety of different stuff in it. So I think it's a good way to showcase what OpenSpace is capable of, but also what we did to make that work. So I'm going to select that as my scene. And then you also have your window options in OpenSpace. These are a variety of configuration options that can give you different windows, of course. It's also possible to write custom configurations, which I'll look at a little bit to give you different ways of working. But for right now, I'm just going to use a basic 720p window, and I'll resize it a little bit once I launch it. I am working on a 4K monitor here. OpenSpace will run in 4K on most machines. I did put a new GPU in this machine right before COVID. But sometimes it can still be kind of slow, especially if you're directly interacting with the GUI in 4K. So I'm going to keep this window a little bit smaller than my full screen, just in case. But you can see I'm loading up a bunch of stuff. It's going to take probably a couple minutes to load everything. While it's doing that, I'll just show you where a couple of these things live. So backing back up into the install directory, we were just in the launcher folder. And of course, like I mentioned, I made that. Also, once you launch OpenSpace, the launcher disappears. So you don't see the launcher window anymore, which can be, again, a little bit confusing. I've seen in some people's experience, especially if you have an error and OpenSpace won't launch, the launcher will just disappear and nothing will happen at all. Or the launcher will stay up and stuck and nothing will happen. So that's why it's good to launch it from the OpenSpace executable the first time you launch, just to make sure there's no basic install errors. All right, and it's open already. But I just want to point out a few things where they live. So config files live in this config folder. This contains all the basic configurations for how OpenSpace can look. Several of them come pre-packaged with OpenSpace. Single fisheye, as you might imagine, is like a fisheye view for a single fisheye projector. Ones like GUI projector and single fisheye GUI are ones that I recommend if you want to create OpenSpace, create an OpenSpace experience where you can interact with one screen of OpenSpace and the audience is seeing another. Such as if you are in a portable planetarium or you are presenting on a flat screen while you do something else on another. Or it's also the simplest way for those who want to stream to generate a window of OpenSpace but not have to see your mouse clicking around on it. So GUI projector and single fisheye GUI will basically cause OpenSpace to open with two windows. Let me crack one of these open. These are all XML files. They're all editable in a text editor. And so yeah, you can see that what this is doing. It's creating two windows for OpenSpace. In one of these windows, basically you will have the rendered view of OpenSpace, and the other one will be black and only the GUI. That way you can interact with the black window that has the GUI, and things will actually happen on the rendered window showing OpenSpace. One catch to know about this, though, I don't know if this is on track to be fixed yet or not, but those two windows have to be exactly the same size. Otherwise, you will get render errors in the window that's actually generating content. So obviously, that's something that does need improved because that's not great. But it's something worth knowing. So like if you are like connected to a fisheye projector and you're doing like I don't even know what my current fisheye projector is. I think it's still 1400 by 1050. So like I want to do a 1400 by 1050 frame for OpenSpace. That means my blank window that I interact with also has to be 1400 by 1050. A little annoying, but something I'm sure is being worked on. And you can edit these. So like if you want a different field of view, a different size, scale, different projection, these are editable. For example, we did, fisheye GUI probably would have done what I wanted, but we did write our own portable dome one. And similarly, if you want to install on your planetarium system, you also will need to create a configuration file for that if you have a multi-channel system. If you do have a multi-channel system and you do want to create one for your planetarium, it's certainly worth like joining the OpenSpace wiki or Slack and getting some advice from the OpenSpace team themselves. But if you have a UniView installed and you've ever looked at your UniView configuration files, this might look familiar because it's basically set up exactly the same way. So if you have UniView, you can basically directly copy your UniView configuration file to make an OpenSpace configuration file. If you don't have UniView, you'll need to see what configuration information is available from your current system. Because the core information, the basic stuff you just really need to know is what field of view each of your projectors or renderers cover. Obviously, you have multiple renderers per projector. Like I know several sort of medium old ENS systems have. It's like 4 renderers per projector. So you would need to know those and program it per renderer. But yeah, you need to know the field of view of each of those and also where it points in the sky. The heading, pitch, roll of where each projector is aimed, and put those together. I think it's also a clockwise or counterclockwise positive, clockwise negative numerical system, which is the technically correct way to orient, but I know is not always consistent because we're a very clockwise culture, it seems. But yeah, this would be how you would write the config file in order to launch OpenSpace on another cluster for the dome. For actually launching it on the cluster, though, version 16 coming out is supposed to have a tool to enable you to launch it on the cluster. But currently, OpenSpace cannot automatically launch on a cluster on its own. The launcher only works on a single computer. So if you do need to launch OpenSpace on a cluster, in my case, I have written a batch script, which I'm pretty sure I've edited to take some sensitive data out of. Yeah. That's actually the demo one. Let me find the right one. There we go. And these are all files. If you are interested in seeing more details of them, I'd be happy to send them to anyone. I don't have a slide with my email, but detail@calacademy.org if you want me to send you anything or give you any more tips on what I've been doing. But yeah, so this is a batch file I've written for Windows to launch OpenSpace on the cluster. I shouldn't say I wrote it too much. I mean, I copied it and I got some help with it. But basically, this uses Windows PS tools, which are some additional downloads you can get from Microsoft. Let me just quick Google that. It's gonna give me the right place. Kind of. But yeah, the PS tools are like these internal additional shell tools you can add to Windows that will allow you to do certain things that you're not otherwise able or encouraged to do. The specific utility here for OpenSpace is launching programs on another computer. Because before writing the script, the way I had to launch OpenSpace is I had to VNC into every one of my renderers and launch OpenSpace on those renderers and then launch it on the master so the master could see they were there and then connect. And also if like something went wrong, like I still had VNC open when I connected with the master, everything would just crash and not work. So it's much easier if you can use a script like this. And again, hopefully in a week or two, this will be obsolete anyway. But basically, yeah, it's a script. It's going through, it's launching, using the PS tools, specifically PS exec, to launch OpenSpace on all of my machines. And what's also good about this, and again, hopefully obsolete, is it has some additional information, this Lua flag, to tell it to load this asset configuration set. And so basically this allows OpenSpace to specifically load a different profile. And so actually on my like Dome machine, I have several different of these launcher shortcuts to launch different shows. Because otherwise there's no way to do it currently. And so, you know, we were doing a tour of the solar system in OpenSpace before COVID struck. We were just about to start doing a tour of the universe. And so we had these utilities built up so that the presenter could launch either or. And in fact, for this AGU event, which I am running the profile for, we also had to like switch horses midstream in that too. So this is a great way to achieve that. Another thing that can be useful too, again, if you're confident with Windows command line utilities, another one that's great to use for OpenSpacey stuff is Robocopy. So Robocopy is Windows Advanced File Copy utility. You can call it up from the command line. And Robocopy lets you do much more sophisticated copying techniques than what you can do on your own. Yeah, through the GUI, basically. It's also often much faster than dragging and dropping things through the GUI. And so this is another example of a script that I wrote where basically it is saying, take all the OpenSpace directories on the master and I guess this one doesn't. Oh yeah, this one does have the flags. Look for anything that has changed on the master and push that out to the cluster. Yeah, it's the very simple like sync command that all of any multi-channel Planetarium system is usually doing in the background, and you don't even notice. Again, OpenSpace is not yet at that point, so this is the fastest way if I am changing content, or even if I've already downloaded a full synchronization on my master, and I just want to push it out to the cluster. Where I can do something like that. And especially because I do a lot of editing of the OpenSpace data directory. Similarly, I have a batch utility like that. So again, hopefully these are things that will become unnecessary with further versions. But if you do want to play around with OpenSpace as it is, it's worth making utilities like this for yourself, or having me email what I did to you so that you can very quickly make changes to OpenSpace, not have to like sit there and copy files to multiple different computers and wait for them, and make sure you didn't accidentally grab the file on the wrong computer and copy it back onto the master and erase all your work, which I say is something that I've done more than once. Yeah, really nice to have just a batch script you can click that will do that hard work for you. So these are all things worth looking into for doing the setup that will, again, hopefully become unnecessary as OpenSpace continues to develop and refine its features. All right, that's a whole lot of background into these configuration files. I guess while I'm at that, I also just want to look at a scene file quickly before I dive into like looking at the OpenSpace GUI. So the OpenSpace scenes are what calls the data that you want to use in your OpenSpace show. They live in, if we go back up to the root directory, they live in the data subfolder and in a further subfolder of that called assets. And so assets basically contains a large number of the reference files that OpenSpace uses to call up assets. The individual assets themselves then get downloaded and synchronized from the cloud. But basically, the reference container files that tell OpenSpace what to do with those assets all live in the assets subfolder. And the root directory of assets is where you would put a scene or profile that you want to use to create a show. So it's where all the ones that are the defaults live, all the ones that come with the install. And a cool thing with them, sort of cool, sort of complex, is frequently they will reference another one to do stuff with it. This has its utilities, but sort of to dive into it. So there is the default scene. If I open that up, you can see the default scene isn't actually doing a ton. In fact, it's mostly doing stuff that I added to it for other purposes and tests. But the main thing it's doing is just setting the time in OpenSpace and setting what objects should be like instant shortcuts and stuff like that. But the main thing to notice is it is calling another scene. These asset.require commands are what tells OpenSpace to load something. It's telling you to require that asset. And so if I look in that base.asset that was called, this is where it's doing most of its work and loading the sun, the planets, the universe, as well as doing a variety of other settings. So that's something to watch out for as you edit OpenSpace. But a cool thing about this too is if I wanted to make another scene that was basically using all the same stuff as the default scene, but maybe starts at a different time, or I just want to add 1 or 2 or 3 assets to it, I can still have it load that base asset. I can make a new scene and I can edit what I want to have loaded in it. You can also send a variety of commands in OpenSpace, basically through the scene file so that it does a bunch of stuff on startup. So in this example, what I'm doing is on initialize, when OpenSpace starts up, setting the trail color for a bunch of the planets to the color scheme that we use at Cal Academy instead of the default colors. I'm also using it to request some WMS map layers to add high resolution terrain to planets that didn't come with it built in, that sort of thing. You can do a ton of stuff in these asset and scene files to pre-create your OpenSpace experience. As for how to know what to do in them, I'll get to that in another minute too. So we're in a scene. I'm in my what I call the AGU scene profile. I'm just going to look at that quick to reference what it's doing. I'm loading what I call the default light asset group that I made. Default light, but by default, the default asset will load the entire digital universe database maintained by AMNH. This is great if you want to do a great big robust tour of the universe. Not so great if you want to do a tightly focused show and don't want a bunch of assets slowing down your load time for OpenSpace. And so for the light one, I basically paired all the digital universe assets I don't use out of that. So I'm only calling ones that are essential to the program I want to do. And then I'm adding a few other assets that were needed for this program. And then there's some other stuff, which I can talk about a little bit more in a minute. So this is basically what I'm doing, loading up these additional assets that are on top of this light version of the profile and giving me my OpenSpace experience. The other thing that I think makes OpenSpace a lot more usable is knowing how to manipulate what you can do in it. So if you've opened OpenSpace, there is a GUI now.
Quick question, Dan?
Yeah.
Hey, are assets live? Can you load them and unload them live?
Yes. You can do it through the command console of OpenSpace, which I'll point out in a little bit, but you can basically send that asset.require command to make it load an asset on the fly.
Oh, nice. Thanks, Dan.
Yes. I haven't done very much with it personally. But it is a way, especially if you're like working on refining something and want to troubleshoot it, to like load and unload as you're working. So looking at OpenSpace now. Most of the GUI, a lot of the stuff you want to see is under this scene button. The scene button contains the hierarchical list of all the objects in OpenSpace. Whatever you are focused on in OpenSpace, which is whatever you are looking at, will appear highlighted at the top of this menu. So I'm looking at Earth right now, but if I change my focus using this focus button and look at, say, the moon, you can see that my current focus selection has changed in OpenSpace, and that's now the thing I'm looking at. This is really helpful so that you don't like have to go down the giant rabbit hole of the hierarchical tree to find what you want. And similarly, anything that you've added in that scene file as a focus you want to be able to look at will show up in this focus menu as a default. But you can also search for any other object or location you've created in OpenSpace and find it through that search menu. So if you're having trouble finding something, you can always search it, focus on it, and then it will appear as your main menu. But if I don't want to work on the moon, as I don't right now, not just yet anyway, I would, expand this hierarchical tree to find the object that I want. So if I want to look back at the Earth, solar system, planets, Earth, and the actual Earth object underneath there, I can hit the focus button there to take a look at it again. There's a lot of additional things. Obviously, there are, labels. There are, those labels are probably not scaled correctly. There is, the marker if you're far away and you want to have the Earth highlighted. The trail is sort of its own object that, is coincidental but separate from the Earth itself. And even the atmosphere is an object I can toggle. All of these things, if I expand them as well, you can see every single variable that goes into them and manipulate all of those variables. This is sort of where, I think OpenSpace has a lot of work to do to grow the GUI into being a more user-friendly GUI. It's a very programmer-friendly GUI right now because you truly can address every single thing that's available to you in OpenSpace, and that's not necessarily going to help you. In fact, a bunch of stuff you wouldn't ever want to touch, but it's there and accessible and really touchable, and you could do some bad stuff. You can always close it and restart if you get yourself into trouble. But the main thing that's worth knowing about under these menus is under layers in particular. Layers is where the cool stuff is because, as I mentioned, OpenSpace's great strength is being able to make use of high resolution map terrain for the Earth or any other planet. And so when you go into layers, that's where you can find this awesome stuff. They're broken out into several groups depending on what planet you're using. But on most planets, the color layers and the height layers are what you want to look into. And I'll do some of that on other planets, but by default, OpenSpace's basic package is provided through partnership with Esri, who, if you don't, they do a lot of GIS software. The default package uses the Suomi NPP satellite, it's directly querying the daily download of data from that satellite. If you're not familiar with Suomi NPP, you might be familiar with its most famous project, the Black Marble Earth at Night data set. But it's a satellite that's whipping around Earth in a mostly polar orbit all the time, taking a picture of Earth every single day. And what's cool about this is you can really see how UniView is querying this data. So if I go to right now, you will actually see that as the data tiles in, it's incomplete because the satellite is still completing its passes for today. So it's still going, it's still collecting the new set of pictures for today. You can see the data stripes as they appear. And so that's why one of the default things that the OpenSpace default profile does is when you launch it, it actually goes back to yesterday so that you get yesterday's image of the Earth. And in fact, if you wind forward, backward, what if I go to, say, 1 month ago? So if you go backward in time, and once it downloads, you will get the download of the Suomi picture of that day. So this is a really cool way that you can do time series data is OpenSpace will automatically, when time series data is available, request data for the date you've plugged into the software. And so I went to September 9th because if you saw the news or talked to me, that was the day we didn't have the sun in California. We've had lots of fires, and you can see the smoke plume from those fires in California in the data set from that day. It's a really cool way to be able to explore current weather, climate, geoscience topics because you can move through time and see those real-time changes on the Earth happening. Hurricanes, storms, snowfall, fires in California, or shortly before COVID, we were covering the fires in the Amazon that had been happening earlier this year. All of this is stuff that shows up in the satellite imagery, and it's great stuff to be able to share with audiences or the public of this. This is real stuff. This is the visible impact humans are having on our planet that you can see from our data collecting satellites. Beyond that, there's a lot of other cool data sets. You can also access any WMS data that works, although not easily. In order to do that, you actually have to bring up OpenSpace's sort of core GUI, which can be done through, I think that's the wrong key. It can be done through a hotkey. I'm not sure. I don't remember which one it is right now. Yeah, there's a few ways to do it, but the easier way that I like to access stuff in OpenSpace, instead of using these GUIs, is just using the GUI, because it can be so hard to navigate, and especially if you want to give a nice, clean, smooth show, you don't want to be digging around and searching. So the big thing that we've done a lot of here at the Academy, which I think has really improved our ability to work with OpenSpace, is taking advantage of the fact that OpenSpace has a WebSocket, which means that you can send commands from any web browser, or at least any sufficiently compatible web browser. Like, don't use Netscape, obviously. Not that anyone could, I'm sure. And definitely don't try and do it with an old version of Internet Explorer either. That won't work for sure.
What about AOL?
Probably not either. But yeah, Chrome or Firefox should work well for as a WebSocket interface to make your own buttons to control OpenSpace. There's another thing where, if you are interested in doing this, I will be happy to share you any of the files that I've made that do this. But it does take a little bit of work to have it happen, because although OpenSpace has a WebSocket, and it actually does have its own built-in web server, which is using to generate its GUI, in order to run your own buttons, you do need to install your own web server on the computer that has OpenSpace. At least your GUI interface of OpenSpace. This is something that's not a huge challenge, but if you haven't done it, it's worth knowing how to do it. In my case, because I am lazy and I like things that are easy, I use a software package called WAMP. I don't think it's even in my system tray right now. But WAMP is a package you can download that is a GUI-based installer that will install for Windows, Apache, a SQL server, and a PHP server, which is great because that's basically what you need in order to host a web page off your computer. This is, of course, not a web page that is live on the internet beyond the Academy. I mean, I can connect to this computer from any other device that's internal to the Academy, but it's not otherwise hosted live on the internet. This is just a web server on my own personal computer that otherwise is not accessible beyond the computer. And that's a setting you can further refine too, depending on what you need. But by installing that web server, I can then host my own web pages that contain the controls to operate OpenSpace. And so if I dive into, I have my WAMP directory that contains my HTML web pages themselves, and I'm going to open up this page that I'm using right now. There's a few additional like JavaScript scripts that it references to do things right. And this was a page originally developed by the OpenSpace team themselves to make their Apollo programs last summer more navigable. But like once I saw this was available, like this really like let us take off and do a lot of cool stuff. And also, again, because I'm kind of lazy, like I just kind of kept it looking the way that they built it, but have otherwise like expanded and built custom buttons to do the things that we want to do. These pages are built with a combination of mostly JavaScript, but you don't really need to know a lot of JavaScript to do the basic stuff because it's already kind of written for you. There's already JavaScript functions built out for how to focus on something, how to look at something, even for basic toggles of turning things. If you want to have a button that is a toggle and turns things on and off, some of that's already built out. And one of the ways that I think OpenSpace is really robust with this is, especially for toggles, you can have your browser query OpenSpace for the status of an object, get that status back, and then make a logic-based decision based on the status of that object. So, I have this Tycho terrain toggle right here. It is asking OpenSpace to return the value of what's the current status of that terrain patch. And then depending on the status of the terrain patch, turn it on or turn it off. This gets into sort of the core thing of like, well, how do you know what to do in OpenSpace? Like, how do you know to write these commands? And that, it turns out, is actually really easy. Anytime you do anything in the interface in the GUI of OpenSpace, like say I turn to look at the moon, and maybe I turn the moon off or on again. Anytime you do something like that, OpenSpace will write it to a place that you can see. If I go back into my OpenSpace directory, back to the root, back to the logs section, there's this handy file called scriptlog.txt. If I open that up, every single thing you do in OpenSpace, it will print the command for what you do into the script log file. So if you need to know how to do anything, just do it in the GUI. Like say, yeah, here I'm looking at the moon. I'll expand it. I will turn on a layer for the moon. I'll turn on the Kaguya spacecraft's imagery. And now when I reload this, there's the command that I need to turn on the Kaguya spacecraft's imagery. And so like learning this about OpenSpace was really like what set us off to the races. Is anything you need to know how to do, you can figure out, if you can figure out how to do it in the GUI, you can get the command that will do it. And then you can write that command into a web page or other control file, however you want to do it. So yeah, if I go back to this, and so yeah, all these commands are just commands of, I did something in the GUI, I copied it out of the script log and pasted it back into the JavaScript frame that sends the command. And this is also really good too, because there are things in the GUI of OpenSpace where the range of values available to you are not necessarily useful. Some things like scaling and terrain, like, you can like scale things up to macrocosmic sizes, but it's really hard to use the sliders built into the software to scale things smaller than 1. But if you can at least get the command out of the script log, then you can rewrite the command to send and change the value that you want. One thing I will note, which has been a big pain for me, and I think has been fixed in other versions of this web page, but I have not done anything with it, is the script log will print commands surrounded by double quotes, but by, at least as I have it written, the JavaScript wants commands to be in single quotes. So yeah, every time I copy something, I have to manually go through and replace all my double quotes with single quotes. Otherwise, nothing will work, and I forget why. And so then I have to like go through and undo and troubleshoot everything until I'm like, oh, I copied a double quote in from the script log. A little something to keep in mind. Shouldn't be like a gigantic problem, but this is what I think really gives like all the cool stuff OpenSpace can do. And you can write in like time delays, you can write in toggles, all kinds of cool stuff to give you a more robust way to control your shows. I think this is also great for streaming programs too, because it's another alternative way to do your streaming. Because I can do things like write a button that just turns off, turns off the GUI. And you can also like turn off the dashboard and stuff so you don't see extra extraneous information. But this is a great way to have a much simpler streaming setup than having sort of the 2 windows, one black, one rendered. Of if you can write all your commands into a browser window and you have a like multi-monitor setup, well, you can just put your browser window in another on your other monitor, have OpenSpace on one, stream from there, and have all your controls for non-flight functions in the web page. So you're never clicking around in the GUI on screen. You're doing everything from commands on the web page.
Hey, Dan.
And then
You mentioned using PHP to make your web interface to OpenSpace. Excuse me. Is there some kind of a glue layer in PHP or your local Apache or something that's talking to OpenSpace, or can you use different web servers in different languages?
So yeah, actually, the PHP was just because that's included in WAMP. I don't do anything specific with PHP itself. Everything I think is handled through JavaScript and over the Apache host. it might be possible to talk to it in different languages. I don't know. The key stuff is, being handled by the OpenSpace API JavaScript file here, which is not well structured. But
it is configured to talk to OpenSpace.
Right. And that's just through connecting on the port. So I don't see any reason why you wouldn't necessarily be able to would not be able to do it with other languages. Basically, anything that can send an OpenSpace string command to the right port should be able to get OpenSpace to do something. Again, I'm sort of just like using what's familiar and easy to me at this point, but it's definitely something of like, yeah, if you can just connect to that socket, you should be able to talk to it in any way, as long as what OpenSpace gets at the end are the strings that it wants. These strings, and everything else is just the framework for how to send those strings, or how to request a piece of data and then send the string back. And so then, I just want to take what few minutes we have remaining to sort of look at some of the other data that can be integrated into OpenSpace. So it's really, really great if you can start off with downloading those built-in packages. But if you find that you want to tell other stories than the defaults, it is possible to add more data to OpenSpace. And one of the big areas we focus on that at the Academy is adding more map data, more high-resolution map data. So by default, there's some really great stuff. And in fact, one of the things that they did a ton of really great work in OpenSpace doing was building out, I'm going to hit some default buttons that are going to do a bunch of little stuff, is building out really great stuff for the Apollo missions. So that's one of those default buttons, is this Apollo Sites button. But let's see, if I take us back in time to Apollo 17's landing, I've done some buttons that have like done a whole bunch of stuff behind the scenes. I am getting some error reports because the Pluto module as built doesn't like to move into the past. It is a bug that has been reported. But now going back in time to Apollo 17, let me just turn a couple other things on. This is an example of, this is all built in, but it can serve as a good example for the kinds of data you can add to OpenSpace. And so what we have on the moon right now is we have our global base layer. In fact, let me open back up the main GUI so we can look at that a little bit. Oh, no, the moon is a subcategory of the Earth. Moon layers. So yeah, in this case, I'm using both a custom height layer, a custom color layer, and a custom height layer in combination to give me my moon base map, and then also individual mosaic strips from the narrow angle camera or other map sources for individual locations on the moon. And this is what really allows you to do that bridging of the cosmic scale and human scale over again, of being able to go from the moon as a world, as this globe that we see in the sky, down to a true scale human level. So yeah, dropping down onto the Apollo 11 landing site, and down to the point of, again, the great work that AMH has done of adding this really nice to-scale photogrammetry model of the lander itself, right where it is, because that little blob of pixels is the lander's remains, the legs, as seen from the Lunar Reconnaissance Orbiter. And I think, again, this gets into that amazing power of what we can do with software packages like this, that power of like creating these experiences. And one thing, like I said at one point, and some of my coworkers keep repeating, is one of the things that like I never really appreciated until we could work with data in this detail is, I think we've all seen the Apollo 17 panorama that was taken by the astronauts on Apollo 17. In fact, Patricia used it in her presentation just yesterday. And used to this image of like these rolling hills of the moon. And one of the things that like really struck me when I could look at it like this is like, oh, these aren't hills, they're mountains. It's just in the photograph from the moon, we don't have any of the depth cueing that we're used to of atmosphere. So we can't tell that they are far away mountains, but yeah, the massifs are these giant mountains. And yeah, you can use and integrate data to explore the mission itself. There's also been great data added of, if I zoom in on the right spot, people have done the photogrammetry work to take the pictures taken by Eugene Cernan and Harrison Schmidt to build out the models of the rocks they were actually seeing. Photogrammetry, if you're not familiar with, is a technique of you take a bunch of pictures from a bunch of different angles, and a computer looks for the similarities and builds a 3D model out of them. And so that's been done with these photographs in the 1970s. And in fact, it's so cool. Speaking of the human scale, if I can find the right spot. Wait, was that it? Yeah, that's it. You can even see boot prints on the moon. So again, things that we can't do with telescopes, but with this combination of simulation software and data, we can tell these stories in a planetarium to actually truly like take people to these places that humans have actually been and make them a real place that you can experience. Now, if you want to add more data that isn't available from either the installs or the servers, that is going to take a little bit more expertise. It's not unlearnable, I think, but it'll take some work. OpenSpace's wiki, fundamentally, let me find the OpenSpace wiki page, which is linked to from here. But the OpenSpace wiki, under the build local dem patches in its menu, does basically contain the instructions for exactly what you need to do in order to add new map data to OpenSpace. And you can do this with tiles of data for the Earth, for the Moon, for Mars, for other bodies. And you can also do global mosaics, for other worlds that are not built into OpenSpace by default. Let me get my time back so I stop getting my Pluto error messages. And we're inside the moon too. That threw out my train of thought. And so this is what we've been doing a lot of at the Academy with OpenSpace over the last year, is adding new data sets that are not built in. Because as you sort of saw, like by default, you have Earth, Moon, Mercury, Mars. But yeah, being able to add more data, and if you also want, I can send any of this to you. You can like go to USGS. I had them right up here. Yeah, USGS. You can get geo-referenced or planetary referenced map data from them there. You can download those, or you can go to individual mission pages. In some point, you can go to get individual CTX or high-rise strips for Mars and add these to the software. And so in all of these cases, these are like here's some series data that we worked with NASA Ames on integrating. These are all cases where there's sort of an information file, the .info, which is what OpenSpace reads. It's what gives it its name in the software, as well as the identifier, which is what the command line script is going to be to work it. And then it references these VRT and or TIFF files, which contain the actual map data itself. There's a little bit of work you have to do, which is covered in the GUI for basically how to write the correct data that OpenSpace can read into these files. And this is all stuff that is done using GDAL, which is a command line set of tools called the Geodata Abstraction Library. You can download these as part of a software suite called OSGeo4W, the open source Geo basically software package, and it contains several pieces of software that work in Confluence to allow you to do a lot of GIS and geodata manipulation work. I'm not going to dive into that into too much detail, but it's something that if you want to get started with doing it, I'm always happy to talk about what we did and how we made this work. It's something we've been doing at the Academy for years, both for producing our rendered shows and integrating high-resolution data into our render productions, but also for getting high-resolution map data into Digital Sky and UniView through our custom-built in-house WMS server, which is all using these open-source tools. Most useful among these tools is a program called Quantum GIS, QGIS, which is a great GUI way to manipulate a lot of map data, but also the command line utilities for GDAL, which will let you do the manipulation of these data sets to bring them into OpenSpace. I don't want that to sound intimidating. It's really cool stuff. It has a bit of a learning curve, but I think that's the thing, is what we want to do in Planetariums is create these experiences. And that means, being able to bring in this data, and it's worth learning about it, I think, learning where to find this data, how to integrate it, and how to manipulate it and work with it so that you are empowered to tell your stories. You're not reliant on, the software update someone else is going to push out. You can go find the data that you want to tell with your stories and bring it in. Here's series with that map data, and then another example of what this map data is doing. This is a combination of the imagery from the Dawn spacecraft as well as the elevation model. So of course, Ceres is being generated as a sphere in the software, but it's a very oblate sphere. And so, all of this terrain is the actual height data coming back from Dawn, merged with the imagery data to turn this giant asteroid, the largest asteroid, again, into a place we can visit on an almost human scale. I'm right here by Ahuna Mons, the great mountain of Ceres, which is, a great example of take people to places that have never been explored before. Let them see sites no one has ever seen. Create these evocative experiences and show them what science is capable of in our modern era to open and expand people's minds, and to reveal both what we know and yet what we don't know. And we've been using this again live in the Academy and also for a lot of our streaming programs. If you do not follow us, we're doing one on Friday that's all about Europa, which I guess is behind me. But that's the case where we've been working with a researcher on Europa and really just looking at what high-res data is available and what stories can he tell using that data in OpenSpace, but also he's going to focus a lot on what we don't know. We only have a fraction of Europa's surface mapped in high resolution. And Europa Clipper is going to be filling out the rest of that. So that's really the core of what I want to get to is OpenSpace is very flexible, very expansible, but a lot of these things that you can do are not well documented and are a little bit hidden. So I always say you should never be afraid of breaking things, because breaking things is how we learn to fix things. And so the best way to learn more about OpenSpace is hopefully I've at least shown you where these things live, where these folders and files live, and given you the gateway to playing with and manipulating them. Actually dive into these scene folders. These are what contain the actual data sets for building stuff out, including adding things that were not in OpenSpace by default. We've added Comet Neowise to it, and you can see what it's not the friendliest to work in to add new data sets, but hopefully things are fairly straightforward and interpretable. And again, this is a case where you can download and add your own data, because here's something that's not documented at all in any of the OpenSpace documentation, in fact, is instead of relying on data that OpenSpace synchronizes down, using this asset.local resource command tells OpenSpace to load a file locally. Something the software is totally capable of that is not documented, but you can write and store your own files that OpenSpace can read and access. So in this case, it is loading a text file of position data for Comet Neowise. And this is just the data I just queried off JPL Horizons. If you're not familiar with Horizons, it is JPL's web server. Hopefully we've all used it at some point in our careers or another. I shouldn't say hopefully. There's a lot of reasons why one wouldn't have to. But JPL's Horizons interface is a great place to go if you want to build out additional stuff in any Planetarium software package, because you can use it to query the positional data for any of the major or small bodies in the solar system and all of our active spacecraft. So in this case, here's what OpenSpace needs currently, and I do want to hopefully provide some input into other ways I think this could be implemented. The data that OpenSpace needs to generate the right format of table, so that it can draw the position of, in this case, Comet Neowise or any other body. And this is the great stuff too. It's a lot of software has relied on being able to build Keplerian orbit tables to draw the ellipses, but that doesn't have the accuracy, especially for things like comets and space missions that are not just a true Keplerian ellipse, or even the fact that we live in a universe that is an n-body simulation, really, to draw these dynamic, complex orbits that space missions exist on. And that's what really lets you have these amazing database stories in OpenSpace that allow you to accurately follow along with NASA's missions, and explore the universe in great, amazing detail.
Hey, Dan.
And yeah,
there was a couple of questions before we get you moving on. I know that we are running short on time. Mark asked in the chat if you're using an Xbox controller to navigate, or using keyboard or some sort of game controller for navigation.
Yeah, I'm using a keyboard and mouse right now, but we do use an Xbox controller, or we have anyway, when we have especially done off-site programs. And it's another great way if you want to use OpenSpace for streaming and not have any of the GUI interactions show up on your streams. Having the web interface and an Xbox controller will basically mean you don't ever have to like put your mouse on the screen. So it does work with Xbox controllers. There are limits to how it can be configured currently. I think it's editable, but I haven't changed anything with that in a little bit. You can also write keyboard shortcuts for any given profile, which is how everything was being done in OpenSpace before we had this WebSocket. Is everything was being written as a keyboard shortcut. So let me see if I can find an example of when you create a scene, you can also create these local key bindings and add keyboard shortcuts that will execute commands with the stroke of the appropriate key. But I like the visual of a web control better. I've already filled up my brain completely with Blender key bindings. I don't have room for any more key bindings.
I'm good with keyboard and mouse. I sure am.
Right.
Another question: do you have any experience using this with VR?
I have not used it with VR, but it is VR compatible. Those are what some of those other config files are. So yes, it should be possible to use it to generate a stereo image for VR. We have also used it in our 3D. We have a 3D theater at the Academy with, a 3D cinema projector. And so also done the same thing there of, in that case, rather than generating a stereo viewport in OpenSpace itself, that's a cluster of 3 machines where each of the machines one of the machines is the master and 2 of them are the 3D eyes feeding into our 3D projector. So yeah, it's definitely capable of doing 3D VR stuff. I just, beyond like that theater setup, I haven't done a lot with VR, but.
All right, and finally, we do have a question. This is actually a question that was asked early on as well. How is OpenSpace different from Worldwide Telescope, and what tasks are each program best suited for?
Yeah, I think that's a really great question because they certainly have some overlap, but and we've used both here at the Academy. We did work with Microsoft Research to install OpenSpace or Worldwide Telescope here 8 years ago when we had an earthquake exhibit, because they were the only software package that sort of met our needs. And of course, although we're a large facility, we are really interested in the open source and free software community. I guess I actually did like a paper at GLPA like 10 years ago, where I was like, Worldwide Telescope's going to disrupt everything with free software. I think the significant difference is OpenSpace is much more focused, I find, on this kind of high data visualization of the 3D universe. Worldwide Telescope certainly has that built in, but I don't think it has the robustness of OpenSpace. Where I think the greatest strengths of Worldwide Telescope are in its sky features. Because if you've used Worldwide Telescope, I think it has that really unique, really powerful feature of being able to overlay multiple sky data sets, but also to zoom in on those data sets in really, really high detail. Also, OpenSpace, unlike Worldwide Telescope, currently does not yet support the AVM metadata standard. If you're not familiar with the AVM standard, all right, and let me, because this is one of those things where, like, if I type the wrong thing, it won't go to the right place. Okay, that's right. If you're not familiar with AVM, AVM is metadata that stores a variety of information about an astronomical picture. And one of the best places to get AVM tagged stuff is from AstroPix, hosted by Caltech. And what AVM metadata has is it has a variety of observational data, wavelength data, but it also contains the positional data for images taken by our space and ground-based observatories. What's great about Worldwide Telescope is you can take an AVM tagged image, as you might download from here, drop it into Worldwide Telescope, and it will appear on the sky where it actually is at the right size. And you can zoom in and crossfade and do cool stuff with that. I recently had to do that. I guess not recently, pre-COVID, had to do that with like some images of the center of the galaxy when we were like producing a video about the Event Horizon Telescope's imaging stuff. That's where Worldwide Telescope's strengths really lie. The things I would say where OpenSpace might give you more versatility and more ability than Worldwide Telescope, I find Worldwide Telescope very poorly documented currently. I know there's an effort to improve that, but specifically the ability to install Worldwide Telescope on a cluster in a dome right now, that documentation is basically out of date. And if you also, there was a good dome dialogue session that got into some of that, and there was some admission from the Worldwide Telescope team that some of this information just is not currently available. So I think, yeah, OpenSpace, much easier to set up in a cluster right now. And Worldwide Telescope does have some high-resolution planetary map data sets, but it does not have as robust an ability, I find, to add your own and manipulate them. It also has web controls and things like that. But in general, I find, in my experience, Worldwide Telescope to be a little more limiting to what's already in the software, whereas I think OpenSpace, because you can crack it open more easily, does have this expansibility that really lets you dig in and customize and manipulate the data in it and add your own data. The other thing, too, I think that helps OpenSpace is it's not a perfect collaboration, I would say, yet, but it is a collaborative project between a variety of institutions. And so there's a lot of stakeholders, a lot of people who have say. And I think this is part of why I do want to evangelize it, is the more people who are using it and the more people who can see, well, it does this and it doesn't do this, I think the more input the community can have into shaping OpenSpace into a fully featured piece of software. Worldwide Telescope, I think certainly there are, especially since AAS took it over, there are ambitions to make it more robust and more usable. But it's had a history of only having a few developers. And I feel like its GUI and its interfaces are not always clear, as well as I think, it's still been in, hopefully there are things happening to it, but I feel like it's been a little bit of a holding pattern on where the development moves forward at this point with Worldwide Telescope, whereas OpenSpace is still in very active development. The NASA grant funding it just got renewed for another 5 years. So the team behind it is very invested in continuing to improve it and make changes to it. And now is a great time to download it and try it out and provide feedback on it.
All right, Dan, we've got just, we're down under about 3 minutes, maybe less than that at this point. But yeah, count me in to help evangelize it. If I latch onto a project, I start making sure the whole world knows about it.
Right.
I love being able to get under the hood on things like this.
Yeah. And obviously, I mean, yeah, I've done at this point, I think like 2 hour-and-a-half presentations on it. There's so much to it. I really just want to give everyone the chance of here's where to look for things. There's a lot of diving in yourself, and I'm always happy to answer whatever questions I have. I believe I've come by the knowledge that I have honestly, and therefore I am eager to share it for free, because it's knowledge I think everybody should have. And so if you ever do want to dive in and what I've said here is too fast to remember, I'm always happy to provide more feedback on what I do with OpenSpace, share files, send files, create examples so that anyone can dive in and play around with it and do more cool stuff. And yeah, I think, like I said, it's not. Yeah.
Email.
Oh yeah, email again. detail@calacademy.org.
Excellent. I just sent you a request. So
I should have made a. Here, I can type it since I'm sharing my screen. If that's not too small to see.
I agree, Julia.
Yeah.
Love breaking things to see how they work.
Yeah, I think that's the key thing, is don't be afraid to do that, because if you do break something, you can always just re-download it and replace it. That's the great thing. You don't have to worry about a whole big crazy install. Just re-download the whole thing, unzip it again, replace your files, and you'll have a working install again. So you can never break anything in a way that's unfixable with OpenSpace. And I think that's great. And if you do make something cool and you break something else, well, you can always make a backup and move your files around again. Yeah. And like I said, it's not a fully featured piece of software yet. It's not a replacement for any of the packages from our excellent sponsors, but I think it's a great tool that augments them and does something different. And especially what it does different really is this integration of really, really good data. into the software in a way that, especially in the early builds, was like so aggressive it would like overflow graphics cards really easily and crash the software. But yeah, it is focused on doing so much with high resolution terrain. And like I said, meeting that dream I've had, I guess, for 20 years of turning these planets into real places that we can visit.
All right.
And I guess that's probably time.
We've got the time. So head on over to the main session. Dan, very good job. Very good job. Thank you so much.
Thanks, Dan. You rock, man. My brain hurts, but you rock.
Thanks,
Right.
Dan.
At least it's recorded, so we can always review again later.